Hello, Sonandra.
Hi, Miss.
So today we are going to study about the function notation. Okay. So first,
Okay.
know what is function. The word function, you can say it is a relation between a set of inputs. So set of inputs and that gives some output. Okay. So suppose we have this equation y is equal to 2x plus 3. So what this equation describes? It describes the relationship between the two variables x and y. So how this is described? Y is equal to 2x plus 3. It means that we get the value of y when 2 is multiplied with some value of x and 3 is added to that. Yeah.
Yes.
Okay. So suppose I take a set of values minus 1 to 2. Okay. So it will be like this. I am taking x as minus 1, 0, 1 and 2. So I will get my y how? Y is equal to 2x plus 3. This is my function. We call it as function. Okay, so y is a function 2x plus 3. This y can also be represented as f of x. Is this clear to you? So whenever it is written as y is equal to 2x plus 3 or it is written as f of x is equal to 2x plus 3, so you consider that f of x is nothing but y. Is this clear to you? Hmm?
Yes,
So
Miss.
now to get this, we are inputting the values of x. Okay, we are inputting the values of x as minus 1, 0, 1, 2 to get the values of y. So when I input minus 1 in 2x plus 3, I get, so it will be minus 2 plus 3, that is 1. Okay, so keep on noting it. And then 2 times 0 plus 3, that will give us 3. Then 2 times 1 plus 3 will give us 5. 2 times 2 plus 3 will give you 7. Is this clear to you?
Yes, Miss.
Okay, now you can see here I have given some values of x, that is minus 1, 0, 1, 2. These values which we are inputting, these are called as domain. Okay, and when we get the values of y, okay, those are called as the range. To say in simple term, input is domain and output is range. Is this clear to you?
Yes, Miss.
Yeah, so you must know how to write the domain. Domain refers to x in this function. So I will write it, x is greater than minus 1 and x is less than equal to 3. Is this clear?
Yes, Miss.
Okay, very good. So we have many types of functions. For example, we can have one to one function. Then you have many to one functions. Okay, one to one function refers that each value will have just like each domain or each number in the domain will have one value in the range. Okay, suppose you, for example, you can see here minus 3 has this 9. Okay, this is different example. I can tell you here itself, this is your one to one function. Okay, so you can mark in your notebook, this is your one to one function. And why do we call it one to one function? Because each value in domain is mapped with one value, one single value in the range. Okay, see, minus 1, 1. Okay, like this. See, minus 1 has got 1. In rest of other values of x, we don't have anyone taking the value of y as 1, right? Every y
Yes.
value of y is different here. Then 0 is 3, then 1 is 5, and then 2 is 7. So you can see all of that, right? So we call it as one to one function. Now when we look at this example where it is, Minus 3 is mapped with 9. See, minus three's value is 9. Then you can see that another number 3 that also has got value 9. Okay. Now you can see here 2 minus 2 and 2, they both have value 4. Okay, and then we have minus 1 and 1, even both of them have value, which value they have as 1 only. Okay, so they both map to one value. So what is happening, it's not like one value is going with one value. Here many values are there for one, so this is called as many to one functions. Is this clear to you? Many to one functions means
Yes.
many values in the domain will map with one value in the range. Okay. Okay, so we'll see some others. Yeah. Yeah,
Yeah.
now this is different. Okay,
Yes.
now here you have 1, 4, 9, 16, and here we have in the range, see we have so many values. So I will write it like this. See, here it is written, when x is 1, y is plus or minus 1. When x is 1, y is plus 1 as well as minus 1. Okay, when x is 4, y is minus 4. One
Okay.
second, no, it is not it is referring to minus 2 and plus 2. Okay, and then when it is 9, it is referring to plus 3 and minus 3. Okay, now one, when your one value of domain is mapping with many values of range, this is not a function. We will say this is not a function. A function must map just one value in the range. Is this clear to you?
Yes, miss.
Okay. Now, what is these functions? It is all those like what we are plotting the graph only, right? Okay. Now, when you have a graph, we can have something called as vertical line testing. Have you ever heard about vertical line testing?
No.
No. So when we do vertical line testing, generally vertical line testing is done to understand whether the given graph or given function is a function or not, to identify that. Okay, so as the word says, vertical line testing, I'm going to draw a vertical line. So like this, see. Okay, so I gave a condition that every value of x should have just one value of y, right? Yes, to be a function, to be a function. Yes or no? You remember this?
Yes.
Okay, so now when I do this vertical line testing, what happens? See, this vertical line is intersecting at one point only that refers to the value of x, right? So here you can say that x is equal to 1, right? At this point. So vertical line testing, and since it is intersecting just at one point, so I can say that this is a function. Is this clear to you? This is a function. Did you get it?
Yes.
Yeah.
Yes.
So this is not the only one type of graph. You can have many type of graph. For example, we can also have a graph like this, suppose, and then let me do a vertical line testing on this graph. Okay, so graph is there. Let me draw a vertical line on this. See, how many places do you think it is intersecting? The graph here and here, right? Yes.
Mm.
So
Yes.
this is not a function. This is not a function. Got it?
Yes.
Yeah. Now we'll see this one. Which of the following mapping show a function? Okay, so can you tell me, looking at these diagrams, which of them are functions? What do you think about
A.
A?
It is a function.
And can you tell me the reason why?
Because the domain is like passed to the range. Like every domain has a different range, but the last one Like it has many ranges, but doesn't have. Uh,
Yes, you can say, because one domain doesn't have two values. Okay,
yeah,
here two domains they have one value, so this is, we can call it as many to one function.
yeah,
Okay, this
yeah.
is many to one function. What about this one? B.
It is
This is a
a
function,
function.
and the reason is that each domain maps with one range.
Yeah.
Okay, so this is a function as well. What about this one?
C is also a function.
C is also a function, because here also, see, each domain maps with one range. Got it?
Yeah.
Yeah. And then what about D? This is a function or not?
No,
And the reason?
because the a single domain is like having two ranges, which is not
Very
possible.
good. Yeah. So when a single domain have two ranges, then, or two values, that is not called as a function. Okay. Yeah. So this is clear to you. So now let me explain you in a graph thing. What is the meaning of actually this domain and range? So suppose if you have a graph like this, okay, and and okay, so okay, and this is our graph. Okay, so this you understand that from here to here is my x values, right, beta?
Yes, ma'am.
Yes. And then from here to here are my y values. Correct.
Yes,
Suppose if I have it like this is 0, minus 1, minus 2, 1, 2, let me say 1, 2, and 3. So, looking at this graph, I will say my domain is from minus 2 to 2. Okay, and when I look at y values, my range is from 0 to 3. Is this clear to you?
yes, ma'am.
Okay, so this is what, when we did that question, y is equal to 2x plus 3, we did this function, right? So what we did, for different values of x, we got some values of y. So that is represented in a graph. Is this clear to you?
Yes,
Okay, so now let's see this one. Give the domain and range of each of the functions in question 2 to 8. So be very very clear, domain is nothing but input and range is nothing but output. Let's see how to understand the domain and how to understand the range. Okay, now,
yeah,
so here you can see the value of x is written as x is greater than equal to 1, means x is including minus 1, I'm sorry, x is greater than equal to minus 1, so x is including minus 1 until where it is less than equal to 3. So value of x will be minus 1, 0, 1, 2, and 3. Now for each value of x we will calculate range. Got it? This
yeah,
is your domain. Is this clear to you? This is your domain. Now I'm going to calculate my range for each value of x. So this is written as f of x is equal to 2x minus 1. I can write this also as 2 of x minus 1. When x is equal to minus 1, y is equal to 2 times minus 1, that is minus 2 minus 1, which is equal to minus 3. This is clear to you?
yeah,
Okay. Now, when x is equal to 0, I must say y is equal to 2 times 0 minus 1, that is minus 1. Got it?
yeah.
Then when x is equal to 1, y is equal to 2 times 1 minus 1, that is 1. Then when x is equal to 2, then y is equal to 2 times 2, that is 4. 4 minus 1 is 3. Then when x is equal to 3, then y is equal to 3 times 2 is 6, and 6 minus 1 is 5. So you can see here, for the values of x from minus 1 to 3, we got values of y from where it is starting, minus 3 to 5, isn't it? We got the values minus 3, minus 1, what else, 1, then 3 and 5. So can I say that my values lie between minus 3 to 5? Can I say this? Will
Yes.
it be okay? So now I have to write these values in form of this thing, in form of inequality. I have to show you, since y is nothing but f of x, so I will write it like this: f of x is greater than equal to minus 3 and less than equal to 5. Did you understand this?
Yeah.
Clear? So
Yeah.
domain is nothing but the values of x which we input, and range is nothing but the values of y which we get after inputting the values of x. Clear?
Hmm.
Okay, very good.